Okay. Probability and odds. Guys, this is the gimme question on your diploma. The absolute gimme to convert between both of them. This is my Lindsay look. Nobody can see how I look. Then Ian's like smiling from ear to ear. Cute. Yeah. Theoretical probability is what we've done. Like when I say to you guys there's a die, and so there's one of these bad boys, and I'm saying what's the probability that you actually roll an even number? What is it? 3 out of 6, which is a half. That's theoretical. That's what should happen. But then there's this other thing in here called the experimental probability. Now, experimental probability is if I gave you the die. So I said, Logan, here it is. Roll this thing 6 times. How many even numbers did you get? And if he only got one even number, his experimental probability is 1 out of 6. So these things can be different. What actually happens in an experiment as opposed to what we know should happen. Like flipping a coin. I can give you a coin and say, flip it. What's the probability of getting tails? It should be 1 out of 2. But if I gave you the coin and you flipped it once and it lands on heads, your experimental probability of getting tails is 0 out of 2 because it never happened. Okay? Make sense? What happens if you do the experiment longer and longer and longer? What happens between the experimental and the theoretical? They should get closer and closer and closer. So if you did it 100 times, flip the coins, it should be close to 50-50. If you did it 1,000,000 times, it'd be even closer to 50-50. Make sense? All right. Which then brings us down to these nice little questions here, which I'm going to ask you guys right now to try to figure out from this little box here. It says 4 black counters, 5 white counters are placed in this bag. One of the counters is selected at random. State the probability that the counter selected is black. What's the probability of getting a black out of this bag? There's 4 black ones out of a total of 9, 4 ninths. Now, not black, and we said this is not black with that little thing. We learned that in set theory. This is also not black if they write it that way. How many things aren't black? 5 out of 9. Brilliant. Okay, the events black and not black are called what? No. No. The opposite one, Logan says. What's the opposite one? Complementary. Okay, these are complementary events. Getting black and not getting black. The sum of the probabilities of these two events, what should it be if we added those two things up? It should always be 1. Okay, make sense? Now we're going to get to odds, because odds are totally different than probability, but they are so closely related. When we talk about odds, we talk about things that we want to happen or we don't want to happen. So I don't really know how they go about explaining this, but let's talk about the odds of getting a black marble up there. The odds of getting a black marble, how many black marbles were there? There was 4. How many weren't black? 5. So the odds of getting a black marble are 4 to 5. I have 4 of them that I could get. 5 of them happen to be there, to be the other color. Then they go a little bit further here, the odds of not selecting black. So right here, the odds against black. Against black. How many things are not black? 5. Opposed to all the other things in there, which is 4. So odds for and odds against. Flip. We have to always read what we're actually looking for each time. Okay, wow, this smartboard is possessed. It's not very smart. Okay. No. So we're just going to All right, same example. We had the 4 black marbles. I'll just put it here so we remember. There was 4 black marbles and there was 5 White marbles, because it's saying refer back to that other example. Now it's saying what's the odds in favor of a white counter being selected? 5, 2, 4. Okay, so that's my odds. The odds against a white counter being selected. 4 to 5. Now what do you notice about the sum of these two numbers each time? They equal 9. They equal how many whatever was in the bag. Okay, so these things add up to 9, 4 and 5, 5 and 4. Now let's go down to this other thing about even odds, where we have a nice little thing about a dude getting a heart attack, which isn't that cool, but after suffering a severe heart attack, Dudley's doctor told him that he had even odds of making a full recovery. Okay, so you're either going to get good or you're not going to get good. It says, what's the probability of Dudley making a full recovery? Now, probability and odds are two different things. So what's the probability of him making a recovery? Basically, of being good. He has one chance out of 2 outcomes. Okay, so he's getting good, that's the one chance, but there's 2 things that can happen. He's either good or things not going to look too good for this dude. Dead. Stephanie has been told that the probability she makes a full recovery is 0.65. Express this in lowest terms first, and then talk about the odds in favor of her making a full recovery. Now, her probability is, 0.65. It says expressed in lowest terms. That's 65 out of 100, which somebody already said to me is what? 13 out of 20. So she has a 13 out of 20 way of recovering. Okay, but now it says talk about this odds of her making a recovery. We'd say there's 13 ways to 7 that she doesn't. Okay, so if there's 13 ways right here that she gets better, this one here is the complement of it, basically. How many ways that she doesn't get better? She has a 13 to 7 chance of actually feeling really bad. Make sense? These things, these 2 numbers here, will always total up to the total number of possible outcomes. Now, reading over this next part, when I looked at it, I wasn't particularly too fond of the question because it actually, well, we'll read and see. When placing bets on the horses, not because it's a horse race, that's okay, the chances that each horse will win are often quoted as their odds. But now in here it says in this horse race, the odds against each horse winning, so this is actually that they're saying that this horse loses. So it's kind of weird that they say that the odds are always what they'll win, and then all of a sudden, but this one tells us the chance that they lose. Because no racetrack posts these, they talk about the chance that they win. But anyways, which horse is the favorite to win the race? So now the question goes from saying, right here, this is how they usually present them. But just to mess with your mind, we're going to tell you this is the odds of them losing. And now the first question says, what's the chance that they win? Okay, how are we getting Free Spirit? So Lindsay actually said, you know what, if I looked at this, if these are his odds of losing, this is his odds of winning. 1 to 2, 1 to 3, 2 to 7, 1 to 8, and 1 to 11. She just was explaining to us that if you look at it this way, of their winning odds, just like flipping everything over, this guy right here will win once every 2 times he races. This guy wins once every 3 times he races. Okay? 2, and then, so they get worse and worse going on. Describe what is meant by the odds 2 to 1 against. He will lose 2 times. Oh, this is just a terrible example. Lose 2 times, but he will win 1 time in a total of what? 3. Yeah, he'd win every 3rd race in this. That's his probability of actually winning. So if we look at this, and I think it gets to the next part right here. His odds of winning are 1 to 2. But his probability of winning, he has 1 win out of how many races? 3. So I kind of described it wrong up here. He has 1 win every 3 races. This guy has 1 win for every 4 races. So I described that wrong up there. So this guy has a 33% chance of winning, 25% chance of winning. This is 2 out of 9 total. So his probability is 0.22 or 22% chance, and it just gets worse and worse. Okay, so let's flip this page and look at what we're going to do and finish this. All right, so we looked at this guy. You got to look back at that other table already to figure out. We had Free Spirit. Now it's saying again, it's winning the race. Free Spirit was 1 to 2. I'll just remind us what these were because we switched the page. This guy was 1 to 3 of winning. This guy 2 to 7 of winning. 1 to 8 and 1 to 11 of winning. So this question you'd never see on a diploma because it goes from telling you something in the positive to the negative, then asking you a question in the positive, and now it's asking you in the positive again. They're doing it so you can really understand what's going on, but it's not well worded. What's the probability of this dude winning the race? A third, 1 out of 3. This guy, 1 out of 4, and then 2 out of 9, 1 out of 9, and 1 out of 12. So we add them up. So we can see that their odds aren't that good. It says, what's the sum of all these? What do you think? If I added all these up, 1/3 plus 1/4 plus 2/9 plus 1/9. Now Carmen's saying, you know what, I need a common denominator. Yeah, you probably do. However, do you have a calculator that works? Yeah, I'd probably use your calculator. There's no way I'm getting a common denominator. Like, we got this. One. Yeah, they all add up to 1. Why? What's 1 as a probability? Like, it's a percent? There's 100%. Why does that make sense in this case? Yeah, one of these horses has to win. There's no other horses we're talking about, just these 5 of them. So if we add them up, one of these horses has to win. Then it says, what's the odds in favor of Foxtrot winning the race? Well, Foxtrot's odds of losing were 7 to 2. So his odds of winning were 2 to 7. So we've talked about this verbatim. We went over it and over it. Okay, so now we have some questions here on this assignment that you guys can rock through. We will get more odds coming up, but just get a handle on these next questions on these pages.